In a previous lesson, I made a key distinction between a simple repository and a specification repository, my terminology. Again, I invented these terms, or at least I applied my own definitions to them, so that I could easily distinguish between querying repositories, either using finder methods like find by make, find by model, find by year, and so on, and a single finder method that allows you to pass in a specification, usually looking something like this: IEnumerable of t, find by, passing in a predicate of type, expression of func of t bool. So in this lesson, what I want to do is break down two implementations of the specification repository and investigate them inside and out so that you can see how and why each of them work. So this first example comes from this article on MSDN. It's Testability and the Entity Framework 4.0. I realize that is an old version, but they haven't updated this article to my knowledge. But that's not really all that important. The part that I want to take a look at is down here in this repository pattern section. All right, and there's actually, you'll recognize some of this code. I reused it and called it something a little bit different for my purposes in the previous lesson. And specifically, I want to hone in on this line right here, this IEnumerable of t, find by expression of func of t bool predicate. So if you're like me, well, I know how to compose lambda expressions to get at the stuff that I want. I sometimes have trouble thinking in lambdas and anonymous expressions or anonymous methods and delegates and things like that. I suppose that makes me some sort of lesser developer. I don't lose a whole lot of sleep about it. Nonetheless, I think it's important to understand what's going on here, because chances are we're going to be using this definition for our own repository methods in the future. I'm not a big fan of the specification repositories like the one here, but I doubt that I can go my whole career and avoid them. So let's start with the return type. You see that it is going to be of type IEnumerable. Now, this example is pulled from a generic repository. I'll talk about generic repositories in an upcoming lesson. I'm not going to talk about that right now. So I don't want to talk about, for example, why we're even using an I repository of t. All right, we'll get to that at some point. The real question is this: why use the generic IEnumerable of t instead of, say, a IList of t or just a concrete list of t? Well, generally speaking, it's considered a better practice to return a type that gives the caller the most flexibility to then cast it to whatever it needs, while still conveying as much intent as required. Almost all collections in the .NET Framework Base Class Library implement IEnumerable of t. It's sort of the lowest common denominator when it comes to collections. In fact, if you take a look at the IEnumerable of t interface, it's basically, if you look through the various methods and such that it forces collections to implement, it basically says, I'm returning a list that can be enumerated through, and that is all. I just promise that this list can be enumerated from the first item to the second item to the third item, and that's it. The client code can then easily cast that to something with more features as needed. It even has, if you take a look here, it has a to list of t, several to dictionaries of several varieties, and a to array as well. Okay, and those help with that very purpose of casting it to something else. If you take a look at IList of t, you'll notice, first of all, that if you take a look at its implementation, you'll notice that it implements iCollection, but also it implements IEnumerable of t. All right. So it has a lot of extra functionality related to managing the items in the list, doing link queries and things like that. But both of those are just interfaces. Ultimately, the client will want to work with a concrete class that implements either or both IEnumerable or IList. Okay. Usually that's going to be a list of t, or if you need a key value style, then it would be a dictionary of t key, t value. And there's nothing wrong with passing a concrete list of t between classes or layers, but generally it's not considered a good practice because it restricts the calling code's options. In the applied architecture series, I suppose I made a mistake in defining the repository interfaces to require list of T instead of IEnumerable of T. All right. So another reason some people prefer IEnumerable of T is for a perceived performance benefit called lazy loading. However, as this blogger points out right here, and scrolling down a little bit ways into his article here, that's really a non-issue in the style of repository that we're working with. He basically says, yes, here at the very bottom, a related discussion is whether or not you should return IEnumerable of T or IList of T. Personally, I think it really depends. IEnumerable is usually used for lazy loading, which means that the collection isn't populated until you iterate over it, such as in a for each loop or by using certain link queries, link methods like toList. This means that if you loop over data in an MVC view, then the data is being retrieved at the time it's being rendered to the view. There are definitely edge cases where this is useful, such as when accessing a navigation property or an entity object, but it's not really useful in the verbose repository pattern that I'm promoting. This is because I like my repository methods to be very specific, which almost always means that whatever data I'm getting back is going to be used because I'm calling specific methods to get specifically what I want, instead of calling generic methods and then filtering through the results. So I always return IList and call the toList link method after my query results in my repository method so that the query is executed and the data is loaded immediately. By the time my data hits my domain, it's already in memory waiting to be consumed. All right, so basically he's saying there's a false promise made by IEnumerable that it's going to give you some benefit, but it doesn't always accomplish that, especially if you're composing your queries in your repository using the find by methods like he suggests, like I suggest, and so on. Okay, so we've covered the first part in our explanation here of the of this line of code. We've talked about the return value being IEnumerable T. How about this next part? This seems to be where all the meat's at. Okay, so this expression of func T bool predicate. Okay, so let's start by keeping things at a really high level here. What we ultimately want to be able to do is something like this on screen. var Toyotas equal repository dot find by e.make equals Toyota, or maybe even var Toyotas repository dot find by, where the make is Toyota and the order by year. All right, so the find by method needs to accept a lambda expression. So we know this, that the expression of func of T bool makes that possible, but the question is how? Well, whenever you see the term predicate used, think the criteria to find a subset. Now, admittedly, predicate is just the name of a variable. He could have named it anything he wanted to. But in this case, he chose the word predicate because that's its fundamental purpose in this little line of code. So a predicate is like a where clause in SQL. It takes a larger set and then it refines the set based on some criteria. Except we're not using SQL to define the criteria. Instead, we're using a lambda expression because they're just so darn compact. So in our car lot, each car is either a Toyota or it's not a Toyota. So this part, func T bool, is a definition for a delegate that accepts a T, or a car in our example, and it returns either true or false. True, the make is a Toyota for this particular instance of car, or it's false, the make is not Toyota for this particular instance of car. So the Toyotas where the make equal Toyota equals true get added to a collection of cars and then returned as an IEnumerable of car. So func is a delegate. In other words, it's an object that knows how to call a method. It can be represented a number of ways, like a traditional delegate, or an anonymous method, or a lambda. They all do the same sort of thing. The method it knows how to call is the one that we create. In our case, it's going to be given E, return those where the make equals Toyota. All right, this is a lambda expression. It's a tiny method that acts as a predicate to find a subset of all of the cars that satisfy a certain criteria. In this case, the make of the car must be Toyota. So this particular delegate, this func t result, is actually built into the .NET framework. It's built in the .NET Framework base class library for convenience. As a result, you don't have to declare a custom delegate that looks like this. So the func t result is a lambda expression. When you apply that lambda expression against a collection, only those items in the collection that match the lambda expression, where the t result as bool in this case is true, will be returned. So hopefully that makes some sense. Again, if you're like me and you don't think in delegates and lambda expressions and anonymous methods, things can quickly spin out of control. So the last question that we have to answer is, why is the func t of bool, which we know to be just an expression, wrapped in this expression, this outermost expression of t? All right. Well, this part is actually a little bit tricky. The func t of result represents the lambda expression that will be executed to return a result. However, the expression of func of t result is an expression tree, or in other words, it's a data structure for a lambda expression that can be interpreted and turned into something else, like a SQL statement that can be executed against a database. So this expression tree structure describes what a lambda expression on the inside does rather than actually performing that lambda expression right away. So expression trees get compiled into something else. So in the implementation of the find by method, it would probably take the predicate and pass it to link to entities. Link to entities will convert it into SQL and execute it against a database like SQL Server. So the rows of data that will come back will only contain cars where make equals Toyota. Those rows of data will then be converted into entities. Ideally, you convert those car entity instances into car DTO instances, or data transfer object instances. You would add them to an IEnumerable of DTO car, or just car, and then return them back. But the key idea is that the predicate expression of func of t result is compiled by the ultimate consumer, linked to entities, or I'm assuming it could be some other link provider to satisfy the lambda expression. Okay, whew. Hopefully that made sense. So there's another example. I've seen some permutations of this find by method in other articles as well. And so the next example comes from this tutorial on the ASP.NET website. It's actually part 9. It's of a larger set of articles. This particular one is implementing the repository and unit of work patterns in ASP.NET.MVC applications. All right, and so if we scroll down to this section called Implementing a Generic Repository and a Unit of Work Class, specifically creating a generic repository, we'll talk about generic repositories a little bit later, you'll see that there is this get method defined. All right, and it too starts off by taking something called a filter. The previous author used the term predicate to describe it, but ultimately it is just a filter. It's a way to help you build a SQL statement that will filter the results in your underlying data store. All right, I guess if you're using SQL Server or some relational database table. But at any rate, it's a predicate. All right, but then there's this other part here, this func of iQueryable of t entity, I ordered queryable of t entity, and a input parameter called order by. And fortunately, this code comes with an explanation below it. Now he discusses the expression of func t entity bool. We'll skip that part and go right here to this part. The code func of iQueryable t entity, I ordered queryable t entity, order by, also means the caller will provide a lambda expression. But in this case, the input to the expression is an iQueryable object for the T entity type. The expression will return an ordered version of that iQueryable object. For example, if the repository is instantiated for the student entity type, the code in the calling method might specify given q, q.orderBy, given s, order by last name, all right, for the order by parameter. So I'm going to talk about iQueryable in a couple lessons from now, but for now, just know that it's an interface that defines a query. The query will be defined with the lambda expressions or the LINQ syntax and is currently under construction and ultimately will be turned into a SQL statement and executed against the database. But for now, we just want to work with the query before it becomes all of that. Given a query, whatever that query turns out to be, order the results that it returns by last name. So it might help to see how you would call this get method that's described here, all right? And so I would call it like this. So var students equals repository.get, given x, return first name equals Bob, and then I'd pass in a second lambda expression for this order by, and that would be q, given q, order q by, given s, order by last name. All right, so you can see how it's used in the implementation of get. If we scroll down into this, here, you take the query object, which is a DB set of type entity, and you've already applied the filter to it in this line of code here, all right? And you might choose to add properties to it, which we're ignoring for now, all right? But then finally, you apply the order by lambda expression to it, which will add the order by s, given s, order by last name to the DB set, and then you call the to list, and that will actually execute it. It won't defer the execution. It will execute it immediately against the database in order to return an actual result. So it's a clever implementation, no doubt. It's just a little obtuse, as in difficult to understand. Or perhaps I'm a little obtuse, as in dim-witted. Both of those definitions might apply in this case. You definitely have to stare at it all for a while. Now, if you're going to use a generic repository, like the one here, and we'll talk about generic repositories later, and you're going to use this specification repository approach with the get method or the find by method that we talked about in this lesson, then this seems like a fine example. At least it comes directly from Microsoft and it has some documentation. But here again, this might brand me as a simpleton, but I prefer the obviousness and the simplicity of the simple, specific repository. Now, hopefully, this is helpful to review these code examples and to dig in and try to understand how they work. If you use these examples as a reference point in your own work, then hopefully they'll give you a little bit of a head start. Or perhaps you'll be like me and you'll realize that this is way more complexity than you're comfortable with, but either way, this should nudge you in one of those two directions. All right, so we're going to pick this back up in the next lesson and move on from there. See you there. Thank you.